I like to welcome now on site here Alar Võrk from Estonia. So the floor is yours. Thank you.
Thank you very much. Hello everyone, I'm Alar Võrk. I'm co-founder and CEO of Lumoflex. We provide smart lighting controls, but as previous speaker already explained very well what these systems can do, I will go a bit more into the kitchen side of how the systems are built and what kind of different technologies that has been used. And maybe bring some bucket of cold water as well into some kind of optimisms, what can be applied. But at first, when we are looking into the streetlight control system, it consists of roughly two parts. One part is LMS, which is the lighting management software, and the second part are those control devices which are on the streets. So they can be luminaire controllers for modern LEDs, so we can apply individual luminaire control, but still a lot of cities have in place all type of luminaires where it doesn't make sense to apply individual control, or even it could be impossible technically to do so. So there is also a cabinet controller, which is in the feeder cabinet where all the power cables are connected, and it can control and monitor all those power cables, switch on and off the power, to switch on and off the luminaires. And of course, one of the key elements in the system is the data connection. And I will not talk about many wired connections, because this is very, very complicated to apply on urban environment because of the long distances between the poles, between the control devices. So there are, when we talk about the wireless communication options for streetlight control, there are mainly three different protocols. There is a narrowband IoT, which is part of the GSM network, where every device can communicate directly in existing GSM network. Of course, you have to pay connectivity fee per device as well. Then there is a low power wireless area network. There are some public networks. There are half public networks, there are proprietary networks, different names, different protocols, but where each node connects with directly to this network as well. And if it's a public network, it's similar to the mobile network. You need to pay the connectivity fee per device, or you just cover the cost of building the infrastructure. And then there is a wireless mesh network where you have one connection point, backbone connection point, with the software for the group of devices, where other devices create a mesh network or a radio network between each other. They can pass the information to other devices and then back to the so-called gateway. And of course, there you can combine also different sensors in the same network, so they can communicate locally. You don't have to route this data through some central management software like with narrowband IoT or low power wireless area networks. But when we now come a bit closer to the control system architecture, in reality, this is a bit simplified view, but the upper part is the user interface, which everyone can see, where they can interact with the luminaires, apply the dimming rules and all these kind of things. One of the important things here shall be that it's some dynamic web application. It doesn't mean that it has to be some cloud-based solution for the customer, but it means that it works on the browser. So you don't need to install some specific software in your computer, which only works on some specific operating system. So dynamic web application allows to access the software from your web browser. So it doesn't matter if you use Windows or you use Mac OS or you use Linux. It works on every operating system. And then there is a backend server where the magic happens. If you put some input, the backend server has application software. It knows what to do. You say, okay, let's put those luminaires into the one group. It applies those grouping in the database. and if you send some command or some dimming profile to the luminaires, it also takes care of the device communication. Of course, there are also communication server, security server, and all these kind of things. Then the next step is from where the server the information goes is the internet gateway or some GSM base station, which also has its own pieces of software. So it can communicate with the server, it can understand what it has to do with the information which it receives from the server or from the device, and it also has this lower level wireless communication software. Either it's low power wireless or it's for the mesh network, so it knows how to communicate in this network. And then finally you have luminaire controller, or you have a cabinet controller there, which also has different layers of software. So it can receive the information, can send the information. It has application software, so it knows what to do, when to dim the luminaire, to which level, when to switch on and when to switch off, and maybe how to implement the data from the external sensors. And then finally it has a DALI software, so it can communicate with the luminaire driver and give the commands to the luminaire driver. So the luminaire can dim or switch on and off. But then there is maybe a bucket of cold water. The first thing what I face very often is in the procurement process requirements for warranty of this kind of control hardware is going up and up. 5 years, 8 years, 10 years, 15 years, sometimes even 20 years. Customers are thinking that, yeah, this solves the problem, this gives me a long lifetime. It doesn't, because warranty only covers the manufacturing defects. And they occur very, very fast. If there is something wrong in the manufacturing process of electronics, it happens very fast. It applies to the control devices, it applies to the luminaires as well. But the lifetime is a different thing. And lifetime is given on some nominal working temperature, which is usually 25 degrees of centigrade. But as we know, our environmental conditions are not stable. Sometimes it's much lower. Lower is not a big problem for the electronics, but the higher temperature is a big problem for electronics. And it's always worth to look what is the lifetime of given lifetime on a higher temperature. And many, for instance, many LED driver manufacturers already have this kind of tables available where they show what is the rated lifetime on higher temperatures as well. Interoperability came into the mention in earlier presentation as well. One big misconception is that if we choose some of those communication options, which are so very often promoted as open source or open communication protocols, yes, they might be. They might not be so open as well. But the communication protocol is only the message carrier. It only can bring the piece of information from one place to another. It doesn't mean that these systems can be interoperable, because there can be used different encryption methods between different vendors, even if you use the same communication protocol. But if the message is encrypted in different way, you send something to the luminaire controller, it cannot decrypt it, or vice versa. And the second is the message content can be different as well, because you can say the same thing in different way. It's like a different language. You get the letter with some unknown language, and you don't know what it means. Same, you can send a command to the luminaires, let's say 10% dim, but one supplier has decided that this number combination means 10% dim. Other supplier decides that there's other number combination which means the same thing. So again, communication technology doesn't ensure the interoperability between the different systems. as we talk about the wireless controls, then one important thing is the firmware update. Because there are constantly technologies are improving, communication technology is improving, so you need to update. Security technologies are improving. You need again to update the software in the devices. I have seen the case which you see on the left picture. Seen the Luminar controller which claims that we have over-the-air update. And then it turns out that you have to take your computer, go to the Luminar, and connect via Bluetooth locally and update each Luminar one by one, separately, on the street. Technically, yes, it is our over-the-air update because you don't need to connect any wires, but it is really what you want to do. So actually, the right term here should be a remote update capabilities. So you can update all the devices directly from the server at the same time. Yeah, there was a bit talk of all the dynamic lighting. This is where we started. We started with dynamic lighting right here in Port of Tallinn, our first pilot with the motion detectors. But there is a but. At first, the control hardware is much more expensive than just Luminar controller, which can apply time-based rules. So the question is, do you dim to some 30-40%, or you dim to 10% and then go up and down, or how much is really the additional savings you can get from there? There is also something what comes to the human psychology. Years ago, there was one startup in Germany, I think it was in 2013-14. They made a street in Nuremberg, dynamic lighting. What happened was the people started to avoid this street. Because when you're walking, light goes up, you start to feel that, okay, I'm on the light spot, but bad people are there, can easily spot me, and can rob me or whatever. So it's not so well taken from the people. And also, when you think of the situation when you're trying to sleep and lights are going up and down behind your bedroom window, that's not that nice as well. Or you watch TV maybe, and then some disturbing light is going. Yeah, maybe they don't go bang in one spot up, a bit slower, but still they're moving up and down. So there are quite limited places where I can see that you can apply really the dynamic lighting. Maybe some parks, not even parks, but car parks. Some really maybe light traffic roads, and also. One aspect is what coming is also to the sensor technology. Passive infrared, yes, it's relatively cheap technology, but the distance is limited. The distance for passive infrared is about 10 to 12 meters. In best cases, it's maybe 15, 16 meters. But if you have a sensor up there, it doesn't mean that it's 15, 16 meters like this. But your pole distance is much, much longer to cover the distance. Also, different weather conditions affect the sensitivity of sensors. And also, about coming to vehicles are driving quite fast. If you take the vehicles driving 50 kilometers per hour, it's about 13, 15 meters per second. Every sensor has a time to react. Within 1 second, you are almost below the luminaire before the light goes up. There are some places here in Estonia where I have experienced the same thing. The light goes up when you are already below the luminaire. So this is something I think needs to be planned very, very carefully where to use really the dynamic lighting. Yes, some other things are coming when we talk about the noise more, not that dynamic, but rather looking at more ambient levels. Then yes, you don't apply on every event. And then it's a bit better. And the third thing, what I have seen on procurement, there is a list, 5, 10, sometimes 15 different parameters, what you need to provide with each luminaire. Current voltage, power factor, has been uptime today, all these kind of different parameters. Yes, technically you can do this, but does it make sense? It's fancy. You have 20 or 50 streetlights, neighbor mayor coming, and you show, oh yeah, you see, this luminaire has current voltage is 228 volt. Oh, this has 223 volt. Does it give you any value? In reality, not. And when it comes to the 1,000 streetlights or tens of thousands streetlights, no one will look at single streetlight. What are these values for these different parameters? Basically, what you want to know is it working or is there failure? That's the thing, because all the power metering, power consumption metering on luminaire level, that doesn't make sense because you pay the bills anyway based on the electricity or power meter which is in the cabinet. And then there is some loss on the cables, and it doesn't match anyway. So this just makes the things more complicated, the system more complicated, more failure prone, and also, of course, more expensive if you apply all these kind of things. Because if you need to route all this information through the wireless network, it also clogs the network, and it's also reliability is lower. Maybe there is some important information which you cannot receive because there is a lot of other information is coming through. But anyway, there are a few things. So I think it needs a careful planning, careful thinking, thinking more about maybe not focusing that much on technical details, how the thing shall be done. Is it a radar sensor, or is it passive infrared sensor? Is it a LoRa communication? Is it narrowband communication? But it's rather to focus on the functionality, what is important for you when you are procuring. Thank you very much. And let's hope the light is on.
Thank you very much, Alar. Unfortunately, we don't have time for additional questions, but okay. Maybe you can point out the most important in one sentence. What you want to say, for example, municipalities, what to improve next time in your procurement? What is the most important thing in procurement?
I think the most important thing is, as I said, the last thing, and not focus that much on putting all the technical details, what has to be in the system. Is it what type of communication and what kind of information, or it's rather look into the functionality. What is important for you? What are the functions? Yes, we need to group luminaires. We need to apply different dimming schedules. Is it really important for you that you apply dimming schedule change in every 15-minute increments? Do you really need 10 different steps on dimming schedule? Do you need all this information on the luminaire? And also, when it comes to the sensors, is it really feasible to use all those sensors? And can they even fulfill your requirements? If you talk about the range in the sensors, and you have...
Can I conclude it that the most important is more deeply just analyze the functionality, because from the functionality depends later all the costs, operation, maintenance, and so.
Yeah, very much, and reliability as well. But the functionality is the key thing. Just to analyze the functionality, what you really need.
Mm-hmm. Good. Thank you very much.
Thank you.